Hey, it's Roger. I'm back, and we're going to pick up here with our MS SQL configuration. It's part of the Azure Sandbox, Azure SQL Database, and we're going to do the smoke testing that's included in the documentation in GitHub. So the first thing we're going to do is we're going to see if the DNS queries are working for the Azure SQL Database logical server. So to do that, we've got to know the fully qualified domain name for our logical server, and it's going to follow this format. So let's pop open the Azure portal and see if we can find that. So this is our logical servers. That's what we're looking for. And there's our logical server. So if we click on that, we should see the fully qualified domain name here under the server name. Okay, so that'll actually resolve on the internet, right? But we're going to not be using public endpoints to speak to this SQL server. We're going to be using private endpoints. We still want to use this same server name, though, for our DNS queries to make sure all the tooling around SQL Server works. So let's copy that. And then we're going to go and log into our jump box, our Windows jump box, using our Bastion. Use our trusty domain admin account. Bootstrap admin at mysandbox.local. We'll grab our password from our key vault. And we'll connect up. Now, I think the smoke testing guidance is to do this test in PowerShell, right? So let's go verify that. It wants us to do a resolve DNS name on the fully qualified domain name for our logical server. So do resolve DNS name, and I'll paste in. Oh, looks like it's not in the clipboard. So let me go back and copy that again from the portal. Here it is. You can always like pop this thing out. This is a Bastion feature that'll show you what's in the clipboard. So the right thing's in the clipboard. So when I do a resolve DNS name, that's the fully qualified domain name that's been registered in Azure DNS for the public endpoint associated with this logical server. And what we can see is that when I query that host name, we've configured our DNS to instead resolve to the private link a record associated with that, which we've set up in a private DNS zone and associated with our virtual network. So when we look at this private IP address, it's the 10.2.2.5 private IP address. So I know that 10.2 is the application virtual network. That's my private network. And I think that .2, if I'm not mistaken, is the private link subnet. Yes, it is. See, 10.2.2. So we know that that private endpoint landed in the right subnet, our private link subnet. So that DNS query appears to be working and resolving correctly. And let's see, smoke testing. So this is just kind of making the point of what all needed to be in place in order to make that work, right? So let's go take a look at that in the portal. If I search for DNS up here, we should see private DNS zones. And I've got 3 of those set up. And the one that we're using for Azure SQL Database is this one. You can tell because it's database.windows.net. So we've set up a private DNS zone, private link.database.windows.net. And if we pop that open, notice here we have an A record for our Azure SQL Database logical server that resolves to 10.2.2.5, right? So how did that DNS query resolve? Because I'm pretty sure that this is not in our private DNS server. Let's go look and see if it is in our private DNS server. This isn't part of the smoke testing, but oh wait, before we do that, this private DNS zone is linked to the virtual networks in the sandbox configuration. So you can see that here in virtual network links. We are linked to both the application virtual network as well as the shared services virtual network. Technically, you should only have to link them to one, but some of the Azure tooling for some various Azure services looks and wants to see that private DNS zone linked to the same virtual network that you've hosted the service in. So, it's the best practice, I think, is to just go ahead and link those private DNS zones to all your virtual networks that are participating in virtual network peering. Okay, so that's set up. Now, if we go pop open the DNS administration tool for our AD integrated DNS server running on ADDS1, if I look at mysandbox.local, there's nothing about that Azure SQL Database, that Azure SQL Database logical server in that private DNS zone. So what's going on here? Why is this DNS query working? And the reason why it's working is if you look at the configuration of ADDS1, and you look at forwarders, you can see that any DNS queries that we can't resolve, we're forwarding to 168.63.129.16, which is Azure DNS. Okay. That saves us from having to add A records to our own private DNS server. We can just reserve that for our IaaS infrastructure, things like virtual machines, domain controllers, things like that. For Azure PaaS services, we're going to use private DNS zones, and we're going to use Azure, and we're going to forward those queries to Azure DNS so that they get resolved. So that's why the DNS name resolution for that Azure SQL Database logical server is working. So let's see, what else do we need to do here? Oh, we're going to test connectivity now with SQL Server Management Studio. So back here on JumpWin 1, let's launch SQL Server Management Studio. And if it's the first time you've launched it, it can take some time. Okay. Here comes SQL Server Management Studio. All right, so I'm going to use that logical SQL Server logical server name, the same one that's the fully qualified domain name for the public endpoint. But I know that because of the way that we've set up DNS, it's going to go through our private endpoint to connect. And we don't have this configured for Windows authentication. We have not domain joined this Azure SQL Database logical server or any of its databases to our mysandbox.local domain. So we're not going to be able to use integrated authentication here. So we're going to switch and we're going to use SQL Server authentication. And if we check our docs here, we're going to use Bootstrap admin as the SQL Server login ID, since we're not using integrated authentication. And we're also going to need the password. So let's go grab that from Key Vault. That's going to be the same as the admin password that we use for everything else in the sandbox. So we'll copy that. And we'll connect. And boom. From Jump Win 1, which is our Windows jump box in the Azure Sandbox, we are successfully connected to an Azure SQL Database logical server using a private endpoint. And if we expand this, we can see here's our test database that we provisioned using Terraform. And I can do stuff like create tables. So we'll call this name. We'll just do name value pair. Make this nvarchar. Let's do nvarchar 50 for the name, and we'll do nvarchar 50 for the value column, and change a property or something to get it to save as something. Oh, here we go. We'll call it save, and we'll call this test values, or test. Yeah, we'll call it test values. Okay. So if we open up our tables, we can now see our test values table, and we can say edit, and we can add some values. First name, Roger. Last name, Doherty. Okay. And I think those were automatically saved. So now if I do a select from here, there's our data. So we're creating tables, we're adding data, we're running queries. No virtual machines involved here. It's all SQL Server as a managed service, which is the Azure SQL Database service. We don't have to worry about patching. We don't have to worry about high availability. We don't have to worry about backup. All of those traditional IT functions are now handled by the managed service. So in the world of shared responsibilities in the cloud, that is now Microsoft's problem to guarantee those things for your Azure SQL database. And you can just focus on building your applications as opposed to managing your infrastructure. So that's a beautiful thing. Let's see here. So the interesting thing about this is we could actually connect to the SQL Server over the public internet environment. Now this is not our Windows jump box. The client environment is my local machine here, right? So I'm going to just do an IP config on my machine from a command prompt. And what are we looking for in that IP config? Scan the results for private link.database.windows.net in the search list. Okay. So the only search list I see is this Comcast one, which is my ISP. So I'm not seeing any private link search lists. So we can attempt to connect to this Azure SQL database over the public internet from this client, which is, my laptop hooked up over my home internet connection. Okay. So we know that private link is not already configured, so that's good. So now I can pull up Windows PowerShell. Let's add a new terminal here. And I can do a resolve DNS name, similar to what I did on JumpWin 1. And we're going to do the DNS name for our Azure SQL Database Logical Server, which is this guy. So I'll copy this server name. And you can see I'm getting a public IP address. So that DNS query is working over the public internet. Okay, so we've gotten to this same Azure SQL Database logical server using a private IP address in our sandbox, but we're also able to get to it from a public IP address over the public internet, right? We haven't connected to it yet, but we can at least resolve DNS queries to that. And, so if I go pull my IPv4 address or we're going to do lookup IP on that IP address that we just returned from PowerShell. So here's this IP address. Copy that. And it says I'm going to use this website lookupip.net. So what can we find out about that IP address? All right, we can see it's a public IPv4 address, a Class A address, and it's running in Azure. Okay. So this is all information about the public IP address we use to expose connectivity to our Azure SQL database over an internet-facing endpoint. Okay. Okay, so now what I'm going to do is I'm going to configure the firewall on the Azure SQL Database logical server to allow connectivity from the IP address for my machine. Okay, so we're going to go to the Azure SQL Database, and I believe the firewalls are in this networking section. And we've got three different options here. Public network access. We've got private access, which is already configured for our private endpoint. and we've got connectivity here. So I think if we want to enable connectivity from the internet, I have to turn this on, and I need to add a firewall rule for my client IP address, which is this first one here. So the Azure portal figured out the IPv4 address associated with my connection, and it's going to automatically add a firewall rule for that. And I'm going to enable this allow access for Azure services and resources to access this server. So that permits connectivity from a lot of surrounding tools in the Azure data platform ecosystem to get connectivity to this SQL Server through the internet-facing endpoint. All right, so it looks like all that stuff worked. All right, so what do we need to do next to test connectivity? So I'm going to launch SQL Server Management Studio, this time on in my client environment. And there it is. Okay. And I've got my SQL Server Management Studio launched. Came up on the different monitor. And we're going to connect up. So I'm going to use, not the IP address, I'm going to use the fully qualified domain name for that SQL server, which we can get here. And we're going to use SQL Server Authentication and use Bootstrap Admin as our SQL Server login ID. And we're going to need the admin password secret, which I can get from Key Vault. And so here what we've demonstrated is the ability to connect to an internet-facing public IP address using SQL Server authentication over the internet from my, home network. Okay. So this would, maybe be a security risk for certain types of database applications. So the next question is, how do I disable that? How do I only allow connectivity through my private endpoint? So we'll go ahead and disconnect from this. I'll drop out of SQL Server Management Studio. And if you go into, okay, this is cool. So we're going to actually make the change using Terraform and have Terraform disable that connectivity. Okay. So if I pull up Terraform, notice I have public network access enabled already set to false. So I had turned it on, using the Azure portal. It was already disabled, as we saw when we were doing our smoke testing. So I turned it back on. So this is now, this configuration and this state file are now out of sync with what's actually up there in Azure, what's actually provisioned. That's called drift. That's a bad thing, right? You always want to use Terraform to make your changes, right? So I've kind of violated a cardinal rule there. So if I go and look at the plan, let's see if Terraform can figure out that this setting needs to be set back to false and to correct that drift. So I'm going to do a Terraform plan and see what Terraform suggests needs to be done. Aha! So it's not going to create any resources if we apply this plan. It is going to change one resource, and it's not going to delete anything. The resource that's going to be changed is our Azure SQL Database logical server. And what it's going to do is change the public network access setting from true, which I did manually using the Azure portal, back to false and correct our drift. Okay, so that was this setting on line 14 of our configuration code. So let's go ahead and do that. And Terraform will now go make our resources in Azure consistent with our configuration and correct the drift. So we see one resource was changed. So that's exactly what we were expecting. Now, if I go look at the Azure portal again, and I pull up that Azure SQL Database logical server, and I go into networking, you can see public access is now disabled, right? So let's see if we can connect over the public internet-facing IP address to this fully qualified domain name from my machine here at home. So let's launch SQL Server Management Studio again. There it is. And it remembered the last server I tried to connect to. So that's still here. We're going to still use SQL Auth. Remember, we're not using AD integrated authentication. But I am going to need my password because I didn't store it. So let's go get our password, our admin password from our key vault. Punch that in here, and we'll click connect. Now we're expecting this to fail, and indeed it failed. So cannot connect, instance specific connection error. Connection was denied since deny public network access is set to yes. Exactly what we were expecting. So just for giggles, let's go back into our sandbox environment on JumpWin 1 and make sure that we can still connect through our private endpoint. So I'll go ahead and exit out of SQL Server Management Studio on my client environment. I think we already still have our Bastion connection to JumpWin 1. So let's just disconnect from this server and close these query windows out. And I'm going to connect again. And it should, it remembers the last server I connected to, which is the one that we're working with right now. We're going to use SQL Server Auth. We're going to connect with the SQL login ID of Bootstrap admin. And I should still have my password in the clipboard. I do. Click connect. And here I can still get in. because I'm going through my private endpoint. So kind of like the whole point of the smoke testing is to show you how the networking and the DNS works for both internet-facing endpoints for Azure SQL Database and private endpoints for Azure SQL Database so that you can properly explain this to your networking and your security people. So hopefully that was a valuable exercise. Let's see what else the smoke testing wants us to do. Yeah, we finished the smoke testing. So in the next video, we'll go through a code review of the different code that's involved in this configuration. So thanks a lot.